right, welcome to Friday. We got a lot of stuff to go over today. We're going to keep talking about inheritance. We're going to talk about slicing. We're talking about virtual functions and override. Why C++ kind of sucks at inheritance and why Java's better, maybe. I don't know. Yeah, we will. We did go over some stuff in the 12 o'clock section that I kind of want to just mention for this class so that you at least are aware of the same topics. Last time on Wednesday, we talked about academia a little bit. We talked about the ranks of academia. And if you're not aware, like the term professor means something different in America than it does in like UK, right? So in the UK, only people who have reached the very pinnacle of academia are called professors. Below that, they're sometimes called readers, lecturers, things like that. In America, we have assistant, associate, and then full professor, right? And calling yourself a professor when you're just a assistant professor was kind of frowned upon in England. But in America, we call anybody who teaches college a professor, so who cares? And below assistant professor, of course, you have adjunct professor and things like that. And then above professor, there are named professors. So, for example, the Lucasian professor of mathematics was taken by like Isaac Newton, right? Like, so when you have a named chair, an endowed chair, there's money that comes with the seat, and when you sit on that chair, you are a named professor. So it's highly prestigious. All right. Then today in the CSI 20 section, we talked a little bit about how to do system administration stuff. Sims asked, what does Unix mean exactly? What's the difference between Linux and Unix? What's the difference between Ubuntu and Debian? And that's kind of a whole thing. But in short, Unix was originally made by Ritchie and Thompson. Ken Thompson and Dennis Ritchie at Bell Labs, now AT&T, I guess you would call it. And they made it on the PDP-11 computer system, and it was kind of like a registered trademark of Bell Labs and things like that. And so, like, what happened was a bunch of Unix-like systems were made, and they're all similar but different at the same time. And I actually worked full-time for a while, actually porting between different versions of Unix-like systems because they're close, but not exactly the same. And, and so you bring it over to Solaris, and, like, Solaris had a different high-performance timer than, like, IRIX or whatever, and so it wouldn't compile, and so that was, I'd compile, and I'm like, okay, and look that up and fix it, and then compile it, and something else broke, and I'd fix it, and yeah, it was actually a good way of getting to know Unix pretty well. Nowadays, most versions of Unix would be... actually, this is useful. So the original Unix is like back in the day. And so all these things are all like Unix operating systems. There's a standard called POSIX that if you conform to it, you're like a Unix-like operating system. Most people are familiar with Linux. If you have an Android phone, then that is running a version of Linux on it. There's also BSD, which is a Berkeley systems division. They have their own thing, and if you were to sit down and use a BSD box, you'd maybe not even notice that it was not Linux, right? It looks pretty similar. And if you use Mac OS, you can open up a terminal and you have a Unix prompt there, yay, But it's also not Linux. It's different. It's its own thing. It derives from NextStep, which was Jobs's big passion project, I guess, after he was kind of forced out of Apple. So yeah, most Unix-like systems these days, that you're probably going to encounter, probably Linux boxes, but Macs are also Unix-like operating system, and there's a lot of BSD boxes around as well. And there's plenty of legacy, activity going on over here as well. So there is in Linux the notion of a Linux distribution, and that, or you can think of them as like different flavors or different varieties of Linux. And it's kind of a collection of like starter software that it comes with, and also like the package manager, like how do you install new software? How do you uninstall software? Fedora, Red Hat has its own thing. I use Ubuntu because Ubuntu is, I don't know, it's designed for beginners, but at the same time, it's reasonably good. So you can update your system like that, and so what that will do is it will contact the Ubuntu servers, and it will check for any software updates on any of the packages that I've installed, and it freezes apparently. I don't know. And this would be a different command on like a different distro, right? And there are many distros that are based on Ubuntu, and Ubuntu itself is based on Debian, which is a slower releasing version of Linux. And then there's versions of Ubuntu like Mint and things like that that are like based on Ubuntu but simplified more for beginners. That is obscene. Look at that. Wow. Slackware. Debian, here's Debian, okay. And let's see if we can find, these are all the versions that split off from Debian. Devuin is Debian, but without systemd, it's a boot system. And that's the kind of thing where the different versions of Linux and also the different types of Unix vary. Like System 5 had its own init system for booting, and more recently we have a boot system that is more than just a boot system called systemd. Some people don't like systemd, and so there's a version of Debian called Devuin that is Debian minus systemd. And name. Oh, fantastic. All right. And so if you look that up. Yeah, it's a fork of Debian that doesn't have systemd in it. Yep. So there's versions of versions everywhere. Raspbian, that's what I use on my Raspberry Pi. Now called Raspberry Pi OS. Somewhere in here we're going to find Ubuntu. It's probably this one. Yeah, there it is. And then Ubuntu has all sorts of different distros that have forked off from Ubuntu. And there's Easy Peasy, which is not my Easy Peasy. It's a different one. Yeah, so lots and lots of distros. And some people like doing what's called distro hopping. Let's see if they have this in here. No. But basically, like, how often do you get updates? How often does your compiler change? And that's an issue that my CSI 45 students are dealing with right now, because I gave them an assignment that needs CSI C++ 20 to do. It uses the likely and unlikely attributes, and these attributes are not in. They're not supported by the compiler that comes with Raspbian. So, oops. So we're gonna have to, either figure out how to build G++ from scratch. I went through the normal build process and it failed. So, oh Lord, here's the thing that gets me, right? Like, if you do sudo apt install, here's how you install something, right? Sudo apt install G++ 11. If G++ 11, if that package exists, that's the most recent update to the GNU compilers collection, G++. It's part of that. You just do that, and it installs, and now you can be like, G++-11, do you exist? Yes, I exist, version 11, cool. But the Raspberry Pi is on Raspberry Pi OS, which is Debian, and Debian has a slower release rate, I guess you might call it. And so if you look at G++ on Raspberry Pi OS, it's version 8. It's 3 versions behind. And so it doesn't support C++ 20 very well. It's 4 years old. There's a lot that's happened in C++ in 4 years, It's still a 4-year-old compiler, right? And so if I were to go onto here, sudo apt install G++ 11 on Raspberry Pi OS, it can't find it, okay? So there's a package for it on Ubuntu. There's not a package for it on Debian, and that annoys me. So, yeah. There is a package for Clang 11, and so Clang is a alternative to GCC. And so you can see that Clang version 11 is in fact available for the Raspberry Pi. However, it doesn't support the likely and unlikely attributes. So, oh well. But that's, yeah, so like Linux users installing a web browser, right? So that's, you know, it's not really a joke. Like, you know, I prefer the command line for everything. Like, I don't like clicking on things. Like, you know, give me a nice command line and I can update all my software at once. Here's all these things I don't need anymore, so I can just do sudo apt auto remove, and that'll delete all the things that aren't needed. You know, okay, cool. Yeah, it's very powerful. So apt is aptitude. That is Debian and Ubuntu's package manager for installing and uninstalling software. It's really nice, except when a package you want isn't available, and then it's like sad. And you can like do something called a PPA, a personal private archive, something like that, where sometimes people will have their own package servers, I guess, set up, and you could install those off of it. But I haven't done that yet for the Pi. So, all right, so that is a little bit of that background on Unix and distros and things like that. People will distro hop; they'll try out all sorts of different distributions. If you want to install Linux Mint, that is a Ubuntu-based system that is designed for beginners, and it's supposed to be really easy to use and stuff like that. Yeah, so some people look down on Ubuntu as being very beginner friendly and stuff like that, but what I find is that when it's popular, there's lots of web pages out there. Like if something breaks and doesn't work, then there's probably somebody out there who has a solution for it on Ubuntu, and I like that. So I just follow the crowd when it comes to Ubuntu, or when it comes to things like that. Like I just tend to go with whatever is very popular, because then if I ever need support, I can find it. And programming and system administration stuff, which is what this kind of stuff is, they're two different career paths. They're two different things, but they do sort of like work well with each other, right? So if you know how to program, you don't necessarily know how to run a Linux box. And if you know how to run a Linux box, you don't necessarily know how to program, but it helps if you know both, you know? So like when I'm trying to do something and the compiler doesn't support C++ 20, it's like, all right, let's do this. Let's try to find a PPA and get the package. And if that doesn't work, download the source and build it from source and stuff like that. So, yeah. There is a X-Credit workshop today at 4:30 run by Benninghoven, who will be talking about how to share your connection. You have a three-person assignment, three-person team assignment coming up due next Friday called RPG 41. It's already out in all of your directories. If you want to start peeping at it and take a look and see what's in there. And it's designed so that there is plenty of space for three different people to work together on the same project without stepping on each other's toes. And Benninghoven will show you a way of sharing one connection to the server, so you can actually have the same Vim screen up if you want to, using a thing called Tmux, which is a really cool tool. I plan on attending and learning about it myself because my knowledge of Tmux is pretty basic, and I'd like to learn more. So installing Python Ubuntu gets Python from the Python servers. No, if you install Python on Ubuntu, it's going to be getting it from an Ubuntu, actually from a mirror, because I have it set up to mirror. I use the Linode mirror servers, and so at some point the Python people put together a package, and then it goes onto the Ubuntu servers to download when people update their software. But Linode has a set of mirrors of all of them, so you don't have to go over the internet. It'll just download in their local data center, and it's very, very fast. So that's how you upgrade all the package on your... I did this earlier, like a couple hours ago, so there's nothing to be done right now. But that's how you can upgrade all of the software on your system. Just one command like that. I have it set to run repeatedly during the day, automatically. What is the difference between apt and aptget? There is no difference. There is a difference. Aptget is the same as apt. Here, let me show you the difference. Apt looks a little nicer. You see how it has colors, right? And it's like erasing the same line. And when you update, there's a little progress bar and things like that. Apt just looks a little nicer than aptget. Aptget is designed for scripting. And so the output of aptget is predictable, and you can feed it, you can pipe it into a thing and see if the aptget worked or not. It's going to do the same thing. Apt just has colors, and it just kind of looks a little bit nicer. So I've actually switched to using apt instead of aptget for most things. Just because that took a lot of retraining, because I typed aptget a lot back in the day. All right. That updates everything. Updates everything. Yeah. So apt, yeah, it has progress bars. It just looks a little nicer. If you're not doing scripting with it, then you're good. Isn't Unix an OS and Linux a kernel? Yeah. So Unix, it's kind of a vague term, right? When I say I teach Unix, it's like, okay, anything that supports like ls and cd and things like that. That's you know. Like I said, there's something called the POSIX standard, and that isn't just ls and cd. It's not really even about that at all, but it's about things like when you call the time function, right? What do you get, you know? And you can see right here, this is part of the POSIX standard, right? And so the POSIX standard has a set of functions that every Unix-like system must implement. And so you can build software on top of the POSIX standard. And if you're POSIX compliant, your code will run on a AIX system, a HPUX system, Solaris, SunOS, IRIX, Linux, whatever. As long as your code is POSIX compliant, you can run the same function and it'll behave the same way in theory on all of these different Unix-like systems. Yep. And your shell, because that was asked also, your shell is the program that reads your command line input. It's actually a program running right now, and when I type ls, it will read that line. It's like, oh, you want to do the ls thing, huh? Okay, and then it displays all the files and folders in the local directory. That's called a shell. The shell is the command line program that handles the command line, and there's lots of shells as well. Everything in the Unix world has 9 million options for it, right? You don't like how it boots up, then use Devuin instead of Debian, you know, and get rid of systemd and put in old init. So if you don't like using TC shell, and why would you, right? I only use TC shell because I'm dumb, right? Bash is much better. Bash is the industry standard. You should learn Bash. Do as I say, not as I do. So Bash is a different program. And if I type ls, look, it does the exact same thing. You know, it's a different shell, but the shell scripting for Bash is different, and it has options that TC shell does not have. The reason why I use TC shell is because I've got all these aliases, and I got my auto completion set up just the way that I like. When I G++ a file, it will not try to autocomplete on the .o version of the file, which is nice. It bugs me having to type in, you know, when you partially complete every time, it's super annoying. And so, for example, if I have ls main start, gcc-c, not gcc, g++-c main.cc. If I have main.cc and main.o here, normally, if I didn't have, here, let me switch into bash, vim main, damn it, setup also there. Oh, vim main, okay. So it is set to ignore the .o file. Okay. And so otherwise it would go main dot, and then it would print the two options, and then you'd have to type cc every time. And so I've got it set up to only autocomplete on CPP, C++, CC, CSX, and H. The compile shell script the same. When I use the Java compile, it only will match on .java files. So a .class file gets ignored. It only will compile a Java file. And so I've got all these things that I've built up over, you know, more than 2 decades of being a nerd, and I just stick with it because I don't want to go to the effort of redoing all of that work. Okay, I've got all my aliases the way I like it, and if I type SL, it does an LS. So in case I'm, you know, doing things real fast and I type SL, it does an LS instead. I really don't want to just go through the effort of redoing all that. It's just because I'm lazy. Bash is better. You should do Bash. Now, if I unalias SL and type SL, you will see that it, of course, prints a steam locomotive to the screen, so which cannot be Control-C'd out of. How much time do you think it would take you to remake it all in Bash? I don't know. I don't know. I could probably do it. Like, I just don't want to. Would you ever try to learn Bash in your free time? Yeah, I've learned Bash scripting before. It's, you know, it's just a thing, you know. But there's no reason from like at least a command prompt perspective that bash doesn't do anything from the command prompt that I can't do in TC shell, as far as I'm aware. That's why I still use TC shell. For scripting, bash is just better. So why does bash not have forward slashes after directory name, but TC shell does? ls. It's just the parameter. So I have it's on alias ls, and so that's what it looks like without the aliases on. I have those aliases in bash as well. This is what it looks like by default when you type ls. It looks garbage, doesn't it? So this is because I have ls-f, and the f puts the slash there. Bash probably doesn't have that. Okay. So that's why. Yeah, just type source.cshrc, but I have an alias for that too. So sc sources your .cshrc file and resets your aliases back the way it was. Okay. I do like that our folders stand out with our ls. Yeah, and that's the thing. Like I've just configured everything the way that I like it, and I'm just comfortable and lazy. Okay, let's move on. Let's talk about inheritance. So last time we talked about the Liskov substitution principle a little bit. Basically, if you have a superclass, then you can pass a subclass to it, and it will work. Now, there's a giant, what is that? README. Who am I? Who am I? What am I doing here? Okay. So there's a giant caveat to that, okay? And what we're going to learn today is one of the big problems with inheritance in C++. And this problem is called slicing, and it is bad, okay? All right? Slicing is bad. And you get slicing when you do this. When you do, and I need to change it up here because we got a friend function up here. So what happens when you do call by value? What does that mean when you do call by value instead of call by reference? What does call by value do behind the scenes? When you do a call by value, what is happening? You've got here, you got here a monkey or something. I'll get all this later. So if I make an animal named monkey, and it's got 100 health and 2 legs, and I say monkey, damage monkey, and I will do 10 damage to monkey. So I changed this a little bit from last time. Animal, damage. Damage animal. Call is ambiguous. Okay. So if I call it, then let's compile the code maybe. Let's try that. Okay. If I compile it, then we do 10 damage to the monkey. I added an IQ also for monkeys. And so it went from 100 health to 90 health. And the damage function now prints your health afterwards. Let's move these clamp functions out of the way. I was kind of making a point about call by reference versus call by pointer. Just drop these at the bottom for now in the code graveyard. Code graveyard at the bottom. All right. So I've got here a function called damage animal, and it now not only knocks off the damage, but it also has them speak each time. And then I could also have a function, that just takes flying animals, so I can't pass an animal to flying animal, right? Like if I tried calling damage and scare, and I tried passing monkey to it, this will not compile, right? Does that make sense to everybody? I've got a subclass of animal called flying animal. I can't pass an animal to a flying animal. It doesn't fly, right? There is no fly function on it. There is no such thing as a flying monkey. Sorry, Alice in Wonderland, or no, sorry, Wizard of Oz, whatever. There are no flying monkeys, right? So I can't pass a monkey to a function that takes flying animal. The animal class doesn't have a fly function on it. It just doesn't work. So the way the substitution principle works is a subclass can substitute for a superclass, but not the other way around. Okay? So yeah, so when you do this, this makes a copy. So when you're doing this, this is actually going to make a copy of monkey. And then if I were to like see out, if I were to do it again, how much health is it going to print out the second time? What do you think? So the first time we call it, it's going to print out, hi, my name is Animal, I'm an animal. I'm at 90 health now because we just took 10 damage. Our max health was 100. I'm at 90 health, I have 2 legs, and I have an IQ of 40. If I damage it again, what health is it going to print this time? Make your votes now. Officials are standing by. It's called by value, it's not called by reference. Should be 80, but it'll probably be 90. You're right, it should be 80, but it will be 90. And the reason why it is going to print out 90 twice is because when we did this, this clones monkey. Okay? Makes a second monkey. And that monkey exists for the duration of this function call here, and then it goes away. And so when we do this, it clones it again. Okay? So we've actually made 3 different monkeys. All normal stuff. But watch, this is actually an amazingly bad thing when it comes to inheritance. Watch this. So I'm going to make a flying animal. Flying animal named Bird. And it's got a health of 40. And it's got 4 legs and 2 wings. Okay? Maybe it's a butterfly or something. Okay. Don't sue me, Nintendo. Okay. Okay. And no, this doesn't clone it. We're about to call damage animal, and we're going to pass in Butterfree. And we're going to do 10 damage to Butterfree. Okay. Now, the flying animal class, for those of you that don't remember from last time, it has an overridden function here that overwrites the base class 1. So rather than it saying I'm an animal with, what is it? I'm an animal with X health and this many legs and this much IQ. Flying animals instead say I'm an animal with this much health, this many legs, and this many wings, right? So what you would think is that when you pass Butterfree to damage animal here, that this speak function will be the flying animal speak, right? Should be, because we're passing a butterfly to it, right? But it's not. And the reason why it's not, and I'll run it for you just so you can believe me. We get the health of the butterfly, we get the legs of the butterfly, we get the IQ of the butterfly, but it did not actually call the speak function for flying animal. Did you see that? We're still passing the butterfly in, but it's not calling the right function. It's calling the original animal function. It's not calling the flying animal speak function. But the values are still there. This is something called slicing, okay? And what happens is that it turns a flying animal into an animal. All the things that make a flying animal special are discarded. The health and legs and IQ are copied over because those are an animal. Those get copied over. 30 health, 4 legs, whatever. Or it was 40 health originally, and then we took 10. But the wings get sliced off. The fact that it has a speak function, that it has its own custom speak function, gets sliced off. It turns into a regular animal. And that's what happens when you do call by value. You do call by value because it's making a new variable of type animal. This is not a variable of type flying animal anymore. It's a variable of type animal, and it copies over the parts of flying animal that it can. So whenever you do this, you always want it to be by reference. Whenever you use inheritance, yeah, you're always going to be passing things by reference or const reference. You remember the rule? Primitives are always by value, and objects are always by reference. That's a rule of thumb. It's not always true. Sometimes you pass a primitive. Sometimes you pass a primitive by reference if you want it to change or whatever. But it's not a 100% rule. It's just in general, when you pass a parameter, if it's a primitive like an int or a float or a double, you pass it by value, and whenever you have an object, you pass it by reference. And inheritance is one of the big reasons why we do it that way. If we pass it by reference, then it actually passes a pointer to Butterfree. It doesn't actually slice it. Okay. So if you pass Butterfree by reference or by pointer, then it actually works the way that you think that it should work. So if we do this and run it, you can see it is now calling the custom speak function for the butterfly. Okay? You guys understand that? Is this the polymorphism stuff that was in the Xi books? Bold of you to assume that I've read the Xi books. So, do you guys get this? So whenever you use inheritance, you always want to pass by reference or by pointer. Never use by value, because then it just turns into the base class. Okay? Slicing. It's bad. You'll be baffled by the errors you get, because you're like, but its health is there, but why is it not calling the right function? Okay, so that's one thing. Now, that's a learning point for today. Slicing. Don't slice your stuff. Now, the other learning point for today is this function here called virtual. And virtual and maybe override are probably the last keywords you're going to learn in C++ this semester. So what does it mean? Well, okay, let me turn it off and show you what it means. So I just turned off that keyword virtual. Let's override as well. I'm going to get rid of virtual, and I'm going to get rid of override. And look what happened here. The only change I made was I got rid of that function attribute called virtual. And you can see that the butterfly is now calling the animal's speak function. It is not calling the proper one anymore. Okay? And the reason for that is because this function here takes an animal. And so if you call animal.speak, it will call the animal speak function, unless you tag it as virtual. When you have a virtual function, then it does something really interesting. But let's just pause there and just see if we can understand why it's doing this. If you have an animal and you call animal's speak function, it will call the animal's speak function, right? We don't know that this thing is, inheritance subclassed, right? We don't know that we're actually passing in a flying animal instead of an animal. Do you guys see that? Like by default, C++ defaults to fast and stupid, right? And so by default, if you call speak on an animal class, it will call animal : speak. That's what it's calling. Okay? What you want it to do, though, is not do that. What you want it to do is say, if you pass it a human, I just made a human class, by the way. So the human class overrides speak as well. And when you have a human speak, it'll say, take your hands off me, you damn dirty ape. And humans default to an IQ of 100 instead of an IQ of 40. That's the only difference. If a human gets sliced, it actually won't do anything because there's actually nothing extra on a human. So if we make a human here, who wants to be my human? I need a volunteer. Shook. All right. So Shook, and Shook will have a health of 100, and Shook will have 2 legs and an IQ of 100. Okay. So if we say shook.speak, it's going to say, take your hands off me, You damn dirty ape. Why? Because we're calling speak on a human. But if we damage shook, then let's have shook speak first and then damage him. Then it calls the wrong one. You see that? Right when he's got an IQ of 100. This is a human that is speaking. It's just calling the wrong function. Okay? Do you guys see this? It's calling the wrong function. Humans have their own speak function, but it's calling the one on animal because the function is calling animal's speak function. So what you really want is when you call speak on animal, you want it to like pause for a second and be like, wait a second, am I actually human? Am I an animal? Am I a flying animal? What am I? Right? You want it, when you call speak, you want it to stop and like hold up a mirror to itself and be like, who am I? What am I doing here? A question that many of you have asked yourselves when studying recursion and linked lists and binary search trees, I'm sure. Midlife crisis, yeah. Yeah, it needs to be like, who am I? What am I doing here? You know? And then you need it to stop and be like, oh, I'm a human? Okay, I'm going to call the human speak function. Oh, I'm a flying animal? I'll call the flying animal speak function. Okay? You guys understand? So I told you that inheritance is a very in-depth method of avoiding an if statement. And this is the if statement that it's avoiding, right? Because what you could do is something like this. You could say int type ID and have, let's type, whatever. And you can have each of these classes tag themselves like I'm a human, I'm a thing, and then you could like say like if I'm a, you know, my type is 10 or whatever, and human's type is 11. You could do that, and then, you know, in speak, you could, I don't know. But the whole point of inheritance is to not have that if statement. You could have an if statement that says like, you know, if mal.type equals 10, cout, I am animal. You know, you could do something like this, right? And just have each one of the classes have their own, you know, thing. And I am monkey. I'm human. Like the whole point of inheritance is so that you don't have to do this. Do you understand? This is like how you have to code if you don't have inheritance. Like if you have one like class for everything, then you have some member variable that says, who am I? What am I doing here? You know, and 10 stands for you're an animal, and 20 stands for you're a monkey, and 30 stands for you're a human, and 40 stands for you're a flying animal. You know, and every time you do something, you would have to check it, right? And have an if statement in there and be like, okay, humans do this, and flying animals do this, and then you have a bunch of functions, and all of them have this. And every time you add a new type, like you're going to add robots or something, then every place where you have all of those things, you have to add another else if thing to it, and it gets kind of complicated and annoying to manage. That's why inheritance exists, so you don't have to do this. This is exactly the kind of behavior they're trying to get rid of. That said, I do it this way most of the time. So, because I hate inheritance. I don't hate it. I just don't like using it. So, if I can get away with it. There are times when I do. So, what we need to do is add that if statement automatically. And we do that via the virtual keyword. This keyword right here, virtual. Okay? Virtual says every time you call speak, stop, look at yourself in the mirror, and find out if you're a monkey. If you're a monkey, do the monkey speak. If you're a human, do human speak. If you're caveman, caveman speak, right? So is that how you simulate classes in Vanilla C? Yes. I can even show you code. Give me 1 second. So here is the source code from Quake. And you can see here, everything, every actor in the world, every entity in the world is one class called entity. And they have a dot class name. They have a member variable called class name that's a string, and it holds their type. I am a sentry gun. I am a force field. I am a player. I am a demon. I am a grenade. I am a... And so if the thing we're hitting is a sentry gun, or no, what is this? Can damage, yeah. So if doing trace line, I see, yeah. Yeah, so if we're hitting a force field, we do this. If we're hitting a this, we do this. If we're hitting a this, we do this. And that's, you know, if, let's see, killed. So target, attacker. So if the person who was hit, if the person who's killed was a player, then it's going to do this. If it's a building, it does this. If it's a... It's all player type stuff. Yeah. If the attacker class name is player and the target class name is player, and they're not the same person, so that's how you do it, right? That's how you do inheritance. Except it's not really inheritance. Everything's in one class. And then you just have a member variable that just says who you are. And then you just have a lot of if statements, okay? And so what this does when you have virtual is that it puts in those if statements for you, okay? So when you say virtual here, what's happening is it will add those if statements for you, and when you call speak, it says, who am I? If you're a human, it calls the human speak. If it's a monkey, it calls monkey speak. If it's a flying animal, it calls flying animal speak. If it's an animal, it calls animal speak. That's what virtual means. Okay? And so when you do that, you can see that now it works correctly. Okay? So when we call speak on that damage function on an animal, we're calling animal speak, but it stops for a second and it looks at itself. It's like, oh, I'm actually shook. And so rather than saying I am a animal with 2 legs and an IQ of 100, instead it says, get your hands off me, you damn dirty ape. Sorry for using the D word. So, that makes sense to you? And here's the thing. A lot of the times you want to have that dot class name thing anyway, because like when you shoot somebody, a lot of times you want to know who did I shoot? You know? And so a lot of times you have to do both. You know, yeah, it's very common to take both approaches, where you have, you know, you have inheritance and you have like a tag or something on it, because sometimes you just want to, like you shoot something and you do double damage against demons. Okay, well you need to know what type it is, right? And there's design patterns that will kind of do that for you, but they're kind of, they have their issues. Let's put it that way. If monkey doesn't have its own speak function, yeah, let's do that. Let's make a monkey class, right? So class monkey, because I keep talking about it as if it was a class, right? So class monkey inherits from animal, and monkey so monkey takes health and legs, and we do the chain constructor thing here, so we're passing on the health and legs to the parent class constructor, so we just pass that on. Monkey's IQ should be, I don't know, 60. And if monkeys speak, they're going to go eek, eek, eek. All right. And so monkey is no longer a monkey, or no longer an animal. It is now a monkey. Officially, it's monkey. And so what you'll see is this thing, rather than saying I'm a monkey, this is monkey, right? I'm an animal with 90 health. Instead, it now says eek, 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 because we've overridden the speak function for a monkey. Now, if the monkey thing wasn't overloaded, yes, it'll use the parent class. Anything that you don't change is going to be left alone. Okay. Remember, it just caught, see, it's the original, but its IQ is now 60. Yeah, anything you don't change, it leaves alone. Because by default, when you do inheritance, it copies and pastes everything from that class in, right? So if you don't change speak, you get the default speak, okay? Does the monkey class have to be under animal class to use : public animal? Yeah, because it won't know what you're doing otherwise, right? So if we put it up here, like that, it's like a who? Never heard of that man in my life. Okay. So, yeah, children come after the parents. All right. The money class, nice. Chimps have an IQ of 14. Monkey say, monkey do. All right. Okay. Any questions about that? So virtual, basically anything that is going to be overridden by child classes, you're going to mark as virtual. That is something that people always forget to do, and then their code acts really weird. They don't know why. It's always calling the base class speak function. I don't know why. Okay. It's a pain. If you forget. Okay. Now, that's why the override function attribute exists. Okay. So override means I am overriding a virtual function from my parent class. And so if you put an override here, this will have the compiler check for you that you are in fact overriding a virtual function. Because you can screw up sometimes, like I did last time, right? I forgot the const here, right? And that's a different function, right? This is actually not going to override this one. In fact, if I don't have that, let's see what it'll do. It might be ambiguous. Nope. And so you see that? It doesn't say eek, eek, eek anymore. Oops. And so I screwed up. That should have been const, right? It has to have the exact same signature to override it. And so if you put an override and it's like you're not overriding anything, you're like, oh shoot, I screwed up, didn't I? Yeah, because I didn't see the const there, right? And so you have to make sure your signature is exactly right. If you misspell something, it'll catch it, right? And so it's a good habit to get into. Only the base class needs to have the virtual keyword, if I remember correctly. And the children classes, you put override. And then it will check everything and make sure that everything is good. Okay, so the override keyword. Learning point number 2 for today. Override guarantees you are actually overriding a virtual function. And that also helps, like if you come up here and you accidentally forget to put virtual, it'll yell at you. Yes, you are overriding it, sort of, but not really, not exactly, not the way you think it should, right? So if you forget to mark something as virtual, it'll catch it. So you basically put things in the parent class that are virtual, the things in the children class are override, and then it makes sure that they sync up properly. Otherwise, you're going to be puzzled. Like my monkey's not saying eek, 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 you know? It's saying, I'm an animal. Why? You know? But when you override it properly, it says eek, eek, eek. Questions? These are the 3 learning points for today. Virtual on the parent, override on the children, and don't slice. Don't pass things by value when you are doing inheritance. Whenever you do inheritance, call by reference, call by const reference, call by pointer. Yep. Do you guys know call by pointer? This is more of a C world kind of thing. Passing something by pointer instead of passing something by reference. And then these things turn into arrows. It's one of the things I like about Java is that it's just dot for everything. You know, you don't have to go back and forth. It's just sort of an annoyance. No, still doesn't like that. Yeah, and then when you pass things by pointer, you have to do the reference yourself, like this. This is a very C way of doing code, by the way. In C, you'll see this passed all the time. So what you're doing is you're saying, I'm passing monkey by reference, essentially. I'm passing a pointer to monkey. And a lot of C people like this, because you actually know I am passing a reference to monkey. I'm not making a copy of monkey. And they like that, because in C++, it's hidden somewhere. Like, am I passing the original? Am I passing a duplicate? And so the C way of doing it, like you can look at it, like I am passing a reference to monkey. That's why call by reference has that reference symbol there, the ampersand. It just hides it, right? And so if you do this, you're passing a pointer to monkey, and you get an animal pointer instead of an animal reference. It's the same thing. If you look at the source code, it's the same thing. A reference is just a pointer. It just isn't scary, right? Because pointers are scary. So look at how scary this thing is now. You got arrows instead of dots. It's scary, all right? So, nothing. There's no difference. This code, call by pointer, this code, call by reference, are exactly the same. It's just the syntax looks a little different, right? You got dot here versus an arrow here. If you were to look at the assembly code generated, they're going to be identical, as far as I know. I don't see why they'd be different. It's the exact same thing. When you do this, when you're passing the address of monkey, that's what happens when you do this. When you pass something by reference, it passes the address of that variable. So damage animal, you do damage and scare like that. And so when we pass Butterfree by reference, it's passing a pointer to Butterfree, and it immediately dereferences it, so it just looks like a regular variable. It basically, call by reference is just call by pointer, but hiding the fact that it's a pointer. And the Java language just took that and made it everything. Every time you pass an object in Java, it's call by reference, essentially. And they use dot for everything. Everything's a reference in Java, except for primitives. Okay. You guys understand this? This will work. Right? Exact same thing. Works fine. When you do call by pointer, it works with inheritance just fine. Okay. Any questions about that? You will see this a lot in C world, right? If you work with C at all, they don't have call by reference, so everything is call by pointer. Anytime you pass a struct, it's going to be usually call by pointer. Anytime you pass something that needs to be changed, it's going to be call by pointer. You're gonna get used to just pointers being passed everywhere in C. If you want to make a directory, right? There's a function called makedir, and you pass it a path name like /home/wkearney/bob whatever, and pass in the permissions, and this will make a folder for you. And it takes a const char*. It takes a string, C-style string. And so you can't really escape from C. You can't really escape completely into a world free of pointers and free of, the Elysium fields, because it's still there. Especially if you're going to be interfacing with old code, or if your company that you work for has old code, it's going to have pointers everywhere and stuff like that. Can't really escape from it. Just resign yourself to understanding how they work. Is C still used? Yeah. Like SDL is a very commonly used graphics interface, and it's in C. And so everything's call by pointer. Everything's called. Yeah, let's see if I can pull up an example. All right, so we want to draw some points on the screen or something. Look, SDL pointer clip null, and then when you pass something to a function, like it's called by pointer there, you got primitives that are called by value, and everything else is called by pointer. All right. When you pass something in, you pass with that little ampersand there in front of it. Right? Just how it is. That's life. Yep. So, it's not even like legacy stuff. Like SDL is still very commonly used. You just kind of have to get used to it. I don't know. But when I write code these days, it's, I avoid pointers as much as possible because there are issues with pointers. Like, I don't know if I'm getting one animal or if I'm getting an array of animals, right? Which one? I don't know. Probably one. I don't know. Like, if they made an array of animals, right? Animal zoo of size 10, I could call damage animal, passing in zoo, and this code compiles and runs just fine. I just made an array of animals, and I pass that into a function that expects it to be one animal. And it compiles and runs just fine. Think about how scary that is. These are different types. They're not the same thing. One animal is not the same as a container of animals. They're different. And it works because it's C. what it's going to do, it's going to damage the health of the first animal in the zoo. So when you do this, this is the equivalent of mal square bracket 0 dot health minus equals damage. These two lines of code are the same. And you don't know when you get a pointer, is it one animal or is it a bunch of animals? You don't know when it's a pointer. Now, if it's a reference, then you do know, right? So if I were to make this and call, let's say, flying animal, zoo, and if I were to call damage and scare passing in zoo, it doesn't work. That's why pointers are better, or that's why pointers are worse, I should say. Because this tells me I am passing in one animal. This tells me I'm passing in, I don't know how many. It'll work with one, it'll work with an array. I don't know. I don't know what this will do. Right? And if I'm really bad off, I might assume that it's an array. And I could do something like this. And I can very happily go out of bounds, because I'm doing CallByPointer. So avoid CallByPointer, except when you're working with SeaWorld. Okay. This code will compile, and it'll run just fine, and it will probably go out of bounds, and it will probably, well, who knows what it'll do. But when you do call by reference, it has type information. This is a flying animal, not an array of flying animals. So it does not compile when you try passing an array to it. Okay. So. Let's see what happens. Works fine. Let's compile it again with address sanitizer on. Let's see what address Let's see what address sanitizer has to say about this. Do you see what we're doing here? So this will work fine. I'm calling damage animal, and I'm going to be setting the life of the fifth animal in the zoo to be 10. Right? This works fine. It's okay. But when I damage this animal here, when I'm damaging monkey, it's not going to set monkey's health to be 10. It's going to go 5 animals in RAM past wherever monkey is and set its health to be 10. Whatever that is. It's probably not even a monkey. It might be your social security number. It's bad. It's really bad. And that code ran, and it didn't complain at all. But now, if I compile it, that didn't compile it. That didn't complain either. That is terrifying. That is actually terrifying that that worked. There we go. Now it detected it, but it didn't detect the other one. That's a little scary, isn't it? Yeah. I'll try that again. Yeah. So it must have still been within the safe boundary. Ooh, that's terrifying. That is really scary. Okay. Yeah. So don't use callby. Don't use CallByPointer. Use callByReference. All right. Now, but it does work with inheritance. There's that to be said about it. Okay. Health. Go to you. And put all these back into the C++ idiom. There we go. All right. Now, let's get into the big issue. Do you have any questions about this? Do you have any questions about slicing? Do you have any questions about CallByPointer? Do you have any questions about virtual and override? So I'm about to get into where C++ is actually terrible. The big enchilada. Looking for an enchilada right now. Pull up some DoorDash. While you guys are thinking about any questions. Come up with a question. This is all complicated stuff. You gotta have some questions about inheritance and stuff. Jack in the Box, mint Oreo shake. New watermelon PFB. What is an int? Nectar juice bar. Mango green tea from the 1920 Tea Club. That looks good. Nothing? You don't have any questions about inheritance? Why do we need to call by reference again? If this was call by value, then it copies everything from this child class into a new variable, because this makes a new variable, right? And that new variable is of type animal, not whatever the child class is. So if you do call by value, it will convert a flying animal into an animal, and it will lose its wings. Okay. Can you show some 41 assignments you've gone over the years? Yeah, I can do that. Does inheritance come with any performance cost, or is it negligible? It does come with a performance cost. In fact, that's one of the reasons why I don't like using it. I like using templates and composition instead of inheritance most of the time. I ran a benchmark actually 2 nights ago that compared the performance of very small functions that are virtual with non-virtual differences, and the speed difference was somewhere between 3 times slower and 8 times slower. Because this adds a if statement, right? Every time you call speak, it stops and it says, am I animal? Am I human? Am I monkey? Right? And that has a performance cost, right? So don't mark functions as virtual that aren't going to be overridden. Okay? Like if you have a getter and a setter, like int get IQ const unless a child class is going to be like overriding that, don't mark it as virtual, right? We'll slow down. Or you can take the approach of, whatever, everything's virtual, and we're just going to eat the speed cost. Yeah. Because you don't know, like maybe somebody will come in and override the getIQ function. Who knows? You don't know. That's part of the problem. It's like you don't know. Maybe they will. So, so that's one of the reasons why I don't like inheritance. For small functions, it has actually a pretty dramatic speed cost. For big functions, who cares? It's an if statement, But there's a big difference between returning a value and doing an if statement and returning a value. Would it be faster in runtime to have those if statements like you showed? No. If you do it manually, it's going to be essentially what the thing's doing for you anyway. When you benchmark hash tables, you're using -02, not 03. Yeah, it would probably have been faster to use 03. Yeah. It's been a while since we learned completely new concepts like this, but it seems useful. Yeah. Now let me show you the pain point. Okay. So we got here monkey, we got here butterfree, we got here shook. And we want to make a vector that can hold all of them. So I'm going to make a vector of animals named vec, and I'm going to say vec.push back monkey, butterfree, and shook. Cool. What just happened? It's copying from monkey into the vector. It's copying from butterfree into the vector. It's copying from shook into the vector. What do we call it when this happens? Let's have all of them speak. Let's have monkey, butterfree, and shook speak. Okay. A monkey, a butterfly, and shook walk into a bar. All right. So when we have them speak, all of them are now animals, right? Now it copied shook's IQ, right? And apologies if your IQ is over 100. It's 50-50, I guess. So monkey's IQ is 60, butterfree's IQ is 40. So it's copying those parts of it over, but it's not actually using the right function because it's been sliced. It's not a human anymore. It's an animal. It's not a butterfly anymore. It's an animal. It's not a monkey anymore. It's an animal. And so all of the speak functions are now gone. It's just using the default animal speak function. Okay, it's copying them. Yeah. So this is different from like if we had these guys speak. And so this is a problem. Okay. This is why C++ is hated. You can actually see this right here. Because if you want to do vectors with animals, with functions it's not a big deal. You just do call by reference, not a big deal. Can you do this? Does that work? Be nice if it worked, right? Nope. Can't do it. So what people used to do is, well, okay, let's make an array of pointers, right? And then we will do CallByPointer with these guys. This, and this is, by the way, hideous. This is really, really bad what we're doing here. And so you, and then it works. Yay, it's a vector of pointers. What could possibly go wrong? Well, let me tell you what could go wrong. When this function returns, all of these variables get deallocated because they're stack allocated variables, right? This is a stack allocated variable. This is allocated on the stack. And so are you, so are you. And so when that function goes away, these guys get deleted. And so who do we have a pointer to? Who do we have a pointer to? We have a pointer to variables that don't exist anymore. And the scary thing is this code will work until the function returns. Once the function returns, all those things have been deallocated. And even then, the scary thing is it'll still probably work until that memory gets overridden. And then all of a sudden it stops working. This is absolutely garbage code. You never want to take a pointer to a stack allocated variable. And by take, let's say, never save pointer to a stack allocated variable. It's really bad. So the second those things go away, in fact, I can probably trigger it. Let's do this. Right, and so here, they go away. And then we're using them after they've gone away. Explosion. Address sanitizer to the rescue. If we compile this without address sanitizer, cycle. Who knows? Could have worked. Who knows? Okay, so we can't do this, right? So we can't do this. And this is the annoying thing, because in Java you can. In Java you can just make a vector of animals like this, and you can basically just, because in Java every object is a reference. Every object is a pointer under the hood. And so you don't need anything special. You just make a vector of animals and you can just add them. And everything in Java is virtual automatically, and so everything you call .speak on it, everything just works. It's actually one area where Java has the upper hand over C++. Not the only area, but it's one of them. Okay. And so let me show you a better way to do this. Remember how we talked about shared pointers? What are you mad about? What are you mad about? Thank you. All right. So rather than doing it this way, and this way is really dangerous, by the way, for a number of reasons. So check this out. So rather than using standard pointers, which you could, and you could push back news on them, what's the problem with this? We have a new, but we don't have a what? No delete. And so we would think, oh, the popback will delete it, right? Nope, the popback just throws a pointer away. So what this code here is doing, let me switch to my tablet. And people used to write code like this, you know, before we had smart pointers and stuff. what happens is we'll have a vector, and the vector will have a bunch of pointers to nude memory. Each one of these is a different animal, right? Each one of them has been nude. And what happens is you call pop back, it just erases the pointer. It doesn't deallocate this memory. So you now got a memory leak. Okay. So what's happening here is that it nudes an animal, adds it to the, it saves the pointer into the vector, and then when you call pop back, it just throws the pointer away. It doesn't deallocate it, right? And so you would think it would deallocate it, but it doesn't. If you want that, you need to use a smart pointer, shared pointer, unique pointer. Okay, so let me show you what happens if we do that. Address sanitizer gets mad at us. Memory leak, right? You got a new, you don't got to delete. So do not write code like that, in my opinion, because you cannot guarantee delete back to that back. You have to do one of these. Or one of these every time. You can't guarantee that'll happen. Okay? Can't guarantee that'll happen. It's very dangerous. So, yeah. You guys understand? This is the bad. Don't do it this way. You guys understand? Don't do it this way. Yeah? No? It's garbage. Okay. So I'm just going to comment this out. And then we will look at the proper way of doing it. Okay. And so what you want to do is if you want to make a vector of animals without slicing it, the simplest way, arguably, is to do it like this. And so you're making a vector of shared pointers of animals called vec. And so rather than just like, you know, doing, I don't know, whatever we had before, like this, animal monkey, and adding it to the vector, you can make a shared vector, a shared pointer this way. Make shared animal, passing in 100 and 2. It's got 100 health, 2 legs. We save that into a shared pointer called monkey. And then rather than calling monkey.speak, it's now monkey points to speak. It's still a pointer, but it's a smart pointer. So it can't leak memory and stuff like that. Any shared pointer you make will deallocate itself when it goes out of scope. Or once there are no more copies of itself in existence, it deletes itself. Do you understand? So this code here makes monkey, and this is, unfortunately, this is heap allocation, right? So stack allocation is faster than heap allocation. That may or may not matter. It really depends where your bottlenecks are. Stack allocation is much faster than heap allocation, but if you're only doing a couple a second, who cares? You know, like how often do you make monkeys in your video game? Probably not that often, right? So who cares, right? But if you're doing it like millions of times a second, then it's going to add up and you need to do something smarter than this. Okay. So rather than making a bat, the Batman, we make a shared pointer bat. You might notice that I typed a little less this time, right? Here I had shared pointer, animal, monkey equals make shared animal, passing in the constructor parameters here. Here I typed a little less. I just typed shared putter, as Art Dwyer puts it, shared putter. Notice that I don't have angle bracket flying animal, and the reason for that is because I don't need it. I have specified flying animal on the right-hand side. It will deduce it for the left-hand side. Cool. A little less typing. It's good. And I'm passing in this bat has 5 health. I think it's supposed to be 50 health, huh? 50 health. It's got 3 legs, and it's got 777 wings. It's a pretty weird-looking bat. And then we have the bat speak. We then make a human called Aaron. And Aaron speaks. Instead of doing it that way, we're doing, oh look, even less typing. See this? Auto Aaron equals make shared human. So basically you don't need any of that up there, just use auto. We all know it's a shared pointer of type human. You know? So we're just do that. It's even less typing. Then you don't have to repeat yourself. Okay. So you can see it's rather verbose doing it this way, but when you get down to it, that's actually not too bad. Like it's still more verbose than the old way. It's not too bad. It's not too annoying, in my opinion. Instead of Aaron.speak, we call Aaron points to speak. So it's going to say, get your hands off me, you damned dirty ape. And yeah. And then we can add it to the vector. So our vector is a vector of shared pointers. And so we just push back monkey, push back bat, push back Aaron, and everything just works nicely. Okay. We can say for every const auto reference, this is very common, by the way. You'll see this construction a lot. Const auto reference any animal. I don't know. Annie, are you okay? I don't know. Annie in the vec. So for every animal in the vector, call speak on it, and it will call the right one because they're pointers. It doesn't slice it. When you do pointers and references, it does not slice. So for every pointer, for every smart pointer in the vector, call speak on that pointer. We then pop Aaron, and this deletes Aaron. It actually isn't going to delete Aaron because there is actually another copy of Aaron right here. So Aaron doesn't actually get deleted until here. But if we wanted to emphasize that point, we could do this. And so the original Aaron does not exist anymore, but we have. So we made Aaron. Okay. Aaron says, "Take your hands off me, you damn dirty ape." We then add Aaron to the vector. At this point, there are two copies of Aaron. There is a shared pointer in here, in main. There's a shared pointer in vector. They're both pointing at the same Aaron. And then this one goes out of scope. And when it goes out of scope, it looks at its reference count. It's like, oh, there were two copies of me before. There's now one copy of me. Don't do anything. Don't delete anything. It just goes out of scope peacefully. But then when this one goes away, when you call vector.popback and it goes out of scope, then it's like, oh, I'm the last copy of Aaron. And then it will free that memory automatically. You don't have to worry about new. You don't have to worry about delete. There are no news in this code. There are no deletes in this code. The memory manages itself. It's nice. This is modern C++, and it is 9,000 times better than how it used to be. Okay? It's actually not bad. Even though you're still working with pointers, you know, like these are still, you know, there's still pointers, and I know pointers are scary, you know, and stuff. You got to use the arrow operator. I know. But basically, there's no news, there's no pointer math, there's no, like, you basically just use these things like regular variables. You know, you just call speak, you know, for every smart pointer in the vector, call speak on it. Like, they're just regular variables. Yeah. Does that make sense? And then, so it's going to print the speak function for all of the animals. Scout all animals now speaking. And then we delete Aaron. So we pop Aaron off the end of the vector. We don't have to have a delete because it's a smart pointer. It just cleans up after itself. It's really nice. And then, yeah, and then we have all the animals speak again. And this time there won't be an Aaron. So let's run that with address sanitizer on. And there we go. So first time through, each of the regular variables are calling speak. I'm an animal with 100 health, 2 legs. IQ is this. I'm a bat, 50 health, 3 legs, 777 wings. So that is the regular variables speaking. And then we then have all of the animals in the vector speak. And you can see it all works. Nothing has been sliced. None of the variables have changed. It's all very nice. And then we pop Aaron off the vector. So the last element in the vector goes away. And you can see now it doesn't say, take your hands off me, you damn dirty ape. And there's no memory leaks. Everything works. Okay. That cool? You guys like that? This is the worst part of C++, honestly. The worst part of C++ because it's not bad. It's not bad. But it's still kind of the worst part of C++. How C++ handles inheritance is kind of, after you've used Java, it's just like, oh man, C++, it's not as good. It's not as good. Yeah, Java's just, I don't know, it's just a little cleaner looking. What's the difference between shared pointers and unique pointers? You cannot copy a unique pointer. You can only move it. And so if you're going to be having a vector and you're going to be grabbing things out of the vector and using it, you can't do it with a unique pointer because you'd have to delete it out of the vector to get it out. And you don't want to be deleting things out of the middle of a vector like ever. So you just copy it out. And then you use the shared pointer and then it goes away. So if you're going to be doing a vector, you could probably make it work with the unique pointer somehow, but I wouldn't I wouldn't. Unique pointers are when you want to have no copies of a pointer, like we did for hash table, right? We used unique pointers. There's not one that's better than the other. It just kind of depends on the needs of your program. Do you want it? Do you want to be able to make a copy of it? Yes or no? That's if the answer is no, unique pointer. If the answer is yes, shared pointer. If you need copies, let's put it that way. And so when something's in a vector, you want to get a copy out of it and use it, and then throw it away and get another copy out, and so shared pointers are kind of thing. Unique pointers are a little bit faster because they don't have to do reference counting, but at the same time, the overhead of shared pointer isn't that bad. So, okay, good question. You might also see something called auto pointer, and auto pointers are garbage. Don't use them. They were a mistake. They're actually deprecated now, I think. Yeah, deprecated. Don't. They actually had a mistake in the standard and couldn't fix it, so they just made a new type instead with the fixes in it. And that one was called unique pointer. There's also these things called weak pointers that are used. Like if you have a doubly linked list, you would never be able to delete your doubly linked list because everything's pointing at each other. And so it would never go away, right? And so you can use something called a weak pointer, which will point at something as a smart pointer does, but it doesn't increase the reference count. So so if your pointer to head goes away, it'll delete the entire linked list for you. It's kind of a less important thing to know about, though. Okay, so are deprecated things discontinued or outdated? Yeah. So basically deprecated means it's still around and the code will compile, but you shouldn't be doing it. There's a better thing. And so like you saw when I changed this to auto pointer, if you try compiling with this, it will say it is deprecated, right? Use something else instead. In this case, use unique pointer instead. So, it's just a warning, but you should pay attention to it. Deprecation warnings are there for a reason. Like, they don't put them in very often, and when they do, you should pay attention to them and update your code. It's the reason why it's on error is because they didn't want people's code to stop working, right? You upgrade to C++ 14 or whatever it was they were deprecated in, and your code doesn't compile. Oh, hell no. People wouldn't upgrade. So basically, they allow you to upgrade, but they'll just start kind of nagging you to fix your code. When did they deprecate that? 11 years ago. Is that 11 then? Okay. Okay. Yeah. Okay, so let's talk about your homework assignment. So you can work in groups of 3. You can self-sign up. I have created the groups on Canvas. And what you're going to be doing is you are going to be making a role-playing game. So this is a famous homework assignment. We've done this for years. And it changes every year. This year's assignment is a little different from last year's if you failed the class and are retaking it. You can't use your old one. So RPG stands for a role-playing game. I sometimes get students asking why we're making a rocket-propelled grenade. We're not. It's a role-playing game. And what you're going to be doing is making a role-playing game using these 5 design criteria. This is not auto-graded. It is graded by hand, and it takes a long time for me to grade them because I have to play all of your games, and that takes a while. Yeah, like I have to sit down over multiple weekends and play them. So don't expect it to be graded anytime soon. There are 5 design criteria. Each design criteria you complete is a letter grade. You complete all 5, you get an A. Complete 4 out of 5, you get a B, 80%. The last point is worth 20 points. The first point is worth 50 points. If you complete 1 bullet point out of 5, you get an F. But it's a high F. You get a 50%. So do at least 1. Every year there's always like some person who's like, I don't know how to do any of this stuff, but I know how to do class design. So I'm going to make a class for heroes and monsters and just turn that in. It doesn't even run. but I did it, you know, and then they get a 5 out of 10. Okay, whatever. And yeah, 50% is much higher than a 0. I would do it. Like, for almost all of my homework assignments, like, there's usually almost no reason to get a 0. Like, for the hash table assignment, I gave you code that, at least for chaining, would allow you to pass all of the input files, all the input tests, right? And even if you didn't do the report and got a 0 on that, that would still be 10 points out of 20, which is much better than 0 out of 20. And I gave you basically working code for linear probing also, right? So a lot of the homework assignments, there's input checking thing where you can just pick up points and pick up points. Like if they type in a negative number, bad input, quit, free point, And so it always kind of bothers me a little bit when a student gets a 0, because even if you're like, I got a physics 4A final or something and I'm busy, like there's just some, like that first point is 50, in this one especially, it's 50% of your grade. Just do one of them, just do one, And the reason why I structure it that way is because once you get that first point done, you're already kind of in, you're kind of working, you got momentum going, you're working on the project, you're feeling good, feeling happy. Like, it's just a little bit more work to do the next bullet point, Now you got a 60%. And then by the time you get to the last bullet point, which is usually the hardest one, like a lot of times it's like, okay, I can do 4 out of 5, no problem. But that 5th one, man, I don't know how to do that. That's why the last one is worth 20 points, right? To give you the impetus to get 100%. Now, there is extra credit available on this as well, which I'll get to after I go through the design criteria. Have you ever had somebody make it using UE4 or Unity? Yes, I have. And you are more than welcome to do it that way as well. You can work in groups of -1 if you'd like. If you can make that work somehow, you can. You can work in groups of 3 or you can work in pairs. It is a self-sign-up system. It is due next Friday. I am not going to be involved in partnering you. You can add yourself to groups. You can remove yourself from groups. If your partners are not responding, remove yourself from a group, and then they will not get any points for it. So don't add yourself to a group with other people without asking them first. So you're like, wow, Otal and Arius, that's a power group. I'm going to add myself to them. No, don't do that. Get permission from the people to join their group first. Please ask. So you can work in groups of 3. It's completely self-sign-up. Okay. There will be one report submitted for each group. The report tells me which of your design criteria you do, as well as extra credit. 1 grade for the entire group. If somebody is sandbagging, if somebody is not contributing, if somebody is not showing up to the group meetings, not contributing any code, move to a different group. Don't give slackers, don't give freeloaders free points. I'm not saying it has to be equal. It never is. No group ever is like 50-50 perfectly. There's always differences and stuff. But what I'd recommend is going to the talk in half an hour by Benninghoven. Learn how to share a session on the server using tmux, and work together. Like book times where you're both free. You can both work on it together. All 3 of you can work on it together if you're in a group of 3, and sit down and grind, work it out. This assignment is designed that there is enough space, there's enough room that one person could be working on the world map, and other persons could be working on the circular linked list, and the other person could be working on the class hierarchy. And it's loosely coupled enough that you can kind of do your own thing, right? So you can actually kind of do the world map separate from like all the other stuff taking place, at least for a while. At some point, you're going to have to integrate them all together, but it's actually designed in such a way that you can get the bridges stuff working on your own without even, talking to your partners too much. Like you have to talk to them a little bit, but it's designed where it can support 3 coders at the same time. Now, let's go through the design criteria. So, the game has to have a functional world map. The world map must allow you to walk around. It must allow you to pick up treasure. You must bounce off obstacles such as walls and oceans and things like that. And you must fight monsters by walking over them. And you must be able to win. There must be a condition for winning the game and arguably for losing as well. The good news is I have given you an operational world map. So, there's Sims, there's Harambe, rest in peace. So if you look at the code that I've given you, this is what you start with. It starts off with a top-down map in a 100 by 100 randomly generated world. There are some ocean tiles there that are the blue tildes. There are some monsters that are the pink M's. There are some walls that are the red hashtag symbol, pound key, whatever you want to call it. There are some yellow treasure chests. By default, you walk through everything. And it's a little scrolling world map until you get to the corners. When you get to the corners, the map stops scrolling. So, yeah, that's kind of done for you. All right? So, no excuse to get a 0 on this assignment. Like, seriously. Like, I will question a 0. Because it's a lot of points. Like, the group projects are worth a lot of points. So, don't get a 0. Please. Okay? Now, you have to make it work, right? Like, right now, you can walk right through the walls, right? You can walk right through the ocean. There's no combat when you walk over a monster. Can't pick up the treasure. But you're given... This is top-down. I'm using the arrow keys, by the way. I'm not hitting return. This is interactive. This isn't see in and see out. Okay? So, this is using a library called Curses, which does interactive mode, stuff like that. And... okay. Alright. Has a max frame rate of 90. Okay. That's probably why I was flickering a little bit. Yeah. Yeah, so basically we can go through how this works. But the main that I give you is just 2 pages. You should be able to figure it out. If you can't figure it out, don't worry about it. It works. Right? There's a function called turn on in curses, and that turns on that full screen text mode. It's like what Vim uses, right? When you Vim, it goes full screen, and you can use arrow keys and stuff, right? This function here turns that on. If you want to turn it off, call turn off in curses. Okay. So if you need to use see in and see out, turn off in curses. When in curses is on, you cannot use see in and see out. Did you guys all hear that? When in curses mode is on, when you have full screen text mode on, you can't use see in and see out. You guys hear that? It's important. It's every time, like, people try see outing all the things, and the words just, because in curses moves the cursor around the screen, and so whenever you see out with in curses mode on, the text will just appear on just random parts of the screen. You're just like, what the hell is going on? If you need to see out something, call turn off in curses, do your see ins and see outs, whatever, and then you can turn it back on when you go back to the world map. Okay? So you can call turn on in curses, turn off in curses. It doesn't quit your program. It just switches you into full screen mode, and then when you turn it off, you go back into your standard see in and see out, hello world, kind of nonsense. Okay. So don't use see in and see out with in curses mode on. Turn it off, do your thing, then turn in curses mode back on again. Okay. And this is all the code. So this is how you get it. This is how you do it in immediate mode. Basically, you hit the arrow key, and that gives you the arrow key. It does not block. It does not wait for you to hit return. You just hit arrow key, and it returns. And then if the user typed the arrow key, it moves to the right. If the user typed the left arrow key, moves to the left. If they type the up arrow key, moves them up. And if they hit the down arrow key, it moves them down. Pretty simple, right? If nothing was typed in, then it returns error. Error is not really an error. It just means nothing's being hit on the keyboard right now. And then if we didn't move at all, then we don't draw anything. But if we changed, then it draws the map and refreshes the screen. Then it goes to sleep. So it wakes up 90 times a second, reads from the keyboard, goes back to sleep again. And that's your starting program. Okay? It's a fully functional kind of thing. Except it's not fully functional. It's mostly functional. I don't know. It's good. It's a good starting point. Let's put it that way. Okay, so you must have a functional world map. You must be able to beat the game, etc., etc. Okay. You must have a class for heroes and monsters using proper class design and inheritance. So those are 2 different things you have to do. So proper class design, if you remember from earlier in the semester, you've been doing this all along, right? We've been hammering proper class design this entire semester, right? Getters, setters, public, private, or now protected, right? Protected if you're going to be doing inheritance, which you are. probably won't need to do rule of 5 and rule of 3 stuff because you're not making a data structure. But like constructor, maybe a destructor if you need to, member function. You guys all know what I'm talking about, right? Proper class design at this point. You should be good. Yeah. And turn off incurses when you want a game over victory screen. Yeah. Or you can do the victory screen in incurses, right? Like there's yeah. You can do it in incurses like this. So, there's Kearney's Castle, right? So, it's on incurses, right? So the map is in map.h, and that's just a random map generator, and it draws the map. So proper class design, you're all good, cool. Victory Screech, yeah, that's fine too. You need to use inheritance. So you're going to have to make a class hierarchy. This will be a good experience for you, making a class hierarchy. Okay? So you're going to make a actor class, and that's anything that can appear in the world. And maybe even treasure might even be part of that. I haven't thought about that. Maybe. I don't know. It's up to you. But actors are anything that appears in the world, and then you can have a hero class, subclass of actors. You can have a monster subclass of actors, and then you can have different subclasses of heroes, one for each class that you want to have in the game. You can have a class for each class. Fighter, rogue, wizard, elf, halfling. If you're going back old school D&D. What class are you? Elf. What's your class? Hobbit. Don't sue us, Tolkien. Halfling. Water as well? You could. I wouldn't. I mean, if water is just... If you just bounce off water, then why make a class for it? Just have it in the world map, and if you try walking over water, you bounce. Simple. Right. Treasure. It's up to you. If you want to have treasure be interesting, like have riddles and stuff, then yeah, I'd probably make a class for it. Bard class, yeah, sure. If you want to make a bard class, you can make a bard class. So, yeah, and then for monsters, you can have goblins, orcs, Kearneys, that kind of stuff. The only thing that you have to have on each one of these is a speed value, which we will see why once we go down to bullet point 4, I think. But, you know, you can put whatever you want on them. Health, attack, defense, whatever. Getters, setters. The only thing that's required is they have to have a speed. Okay. And, yeah, so build a class hierarchy. That'll give you good experience doing this kind of stuff. And you can, you know, like I said, the details are up to you, right? I'm just kind of generally giving you design criteria. And again, each one of the design criteria you do is free letter grade. So, you must hold all of the heroes and monsters in a data structure, right? That's what we just talked about today. So rewind the YouTube video to half an hour ago and look at how I made a vector of animals using smart pointers, okay? And you must make it so it does not slice them, okay? So no slicing allowed. Don't slice your stuff. Yeah, and you have to use smart pointers as well. So a vector of smart pointers is probably the way I would do it, but you know, it's a free country. If you want to make a linked list of smart pointers, like it's your life. It's fine. Fstream, yeah, if you want. For loading and saving, yeah. Fstream is probably how I would do it. If you're in CSI 45 right now, Aaron and Mincarelli, we went over how to do memory mapped files. You could teach them how to do mapped files if you want. Or not. I would just use Fstreams. So you have to be able to save the game and load the game. And it saves the state of the world. That's one of the things that I test for. I come in, I launch your game, I play it a little bit, I quit, save and quit, come back in, it needs to be able to reload the game again. Okay? So whatever state the world was in, you can save it to disk and reload. Because what kind of video game, you know, can't save, right? Small games, I guess. And so you should have an option either to make a new game or an option to continue, basically. NES games, yeah. Well, yeah, I mean, Zelda, things like that, they had the battery backup, you know, so you could save the save your progress. Final Fantasy had a battery backup. And I played Final Fantasy 1 in 88? 87. 87. When I went to college, and I was a sophomore in college in 96 and 97. So that'd be 20 years later? No, 10 years later. Sorry. I can do math. 10 years later. I discovered my NES again and found Final Fantasy, and I put it in. My save game still worked. The battery backup actually worked for 10 years. And I was able to complete, you know, my game in college 10 years later. It's kind of cool. I doubt that it would work now, though, for some reason. Versions and re-releases. They've re-released it a lot. Yeah. Okay. So anyway, yeah, it was kind of fun. Like, oh, I remember that game. And you finish it, you know, for when you were a kid. I was like, what, 9 or something, and then I played it when I was in college. Okay. Yeah, so when you walk over a monster, you have to switch to a combat screen. And so I would do this by turning off incurses and then doing combat with incurses off, unless you want to figure out how incurses works. I'm more than happy to teach you on Monday about how incurses works. Simplest way would be to just turn off incurses, do your see-ins and see-outs and things like that. Then when you finish, turn incurses back on and go back to the world map again. Simple. Now, the way that combat works is you are going to have to take all of the... You're going to have multiple people fighting, multiple heroes, multiple monsters on the same screen at once. And not one-on-one. One-on-one does not count. You must have at least 2 heroes. You must have at least 2 monsters, right? And you sort them by their speed. So whoever has the highest speed goes first in combat. Whoever's second highest goes second, so on and so forth. And there's an example here of that. You must store it in a circular linked list. So a circular linked list is a linked list with a head and a tail, but the next of the tail is head, and the previous of head is tail. So you don't even need tail. Right? It's just head dot previous. So a circular linked list, append at the back is just you're appending to heads previous, and yeah. Push front and push back look very similar, right? Because it's a circle. Just depends if head changes or not. So you're going to have to make a circular linked list. I have provided a sample source code implementation for circular linked lists in the directory, and it is from Bridges. So if you were to look at circ DLL list like this, you can see that there are functions to insert at the front. There are functions to insert to the front. Where's the class? Yeah, maybe that's the whole thing. Okay, yeah. So it's got some demo code that builds us the circular linked list. Yeah, so it just calls insert front a bunch of times. That's it. That's the entire data structure. Okay, so you're just gonna do that, and then yeah, and it has code to insert at the front because there's no insert front or insert back. It's all basically the same thing. It's a circular linked list. So you have working code. You should be able to do this pretty well, pretty easily. Okay. So when you go into combat, build a circular linked list holding all of the people. And the reason why it's a circular linked list is so you can keep going to the next, go to the next, go to the next, go to the next. It's like when you're playing poker. When you get to the end of the table, you go back to the beginning again, right? It just keeps going around. And as people fold, they get deleted out of the circular linked list, and it gets, you know, lower and lower in count until, you know, the monsters are dead or the players are dead, basically. Okay. So, yeah, that's a whole letter grade, and I've basically given you the code to do a circular linked list. So that's cool. And then point 5 is bridges. You must visualize the turn order. So if you ever played a role-playing game, you know that usually they have a initiative list or a turn order Divinity Original Sin 2, one of my favorite RPGs of all time. Has anyone here played DOS 2? It's up here at the top. That they have the turn order, right? And this is a circular linked list. When one person goes, they move to the back. And then the next person goes, and they move to the back. You can see here A and B, A and B. See that? It's a circular linked list. Then he goes, and it goes to the back. And then they go, and it goes to the back. You can always see who's coming up in the turn order. That's the whole point. Okay. You were about to buy it last year. The nostalgia is pretty intense. Yeah. Final Fantasy is a great game. I wish Final Fantasy 1, like, I wish it had just a little bit more content to it, because it's kind of sparse. It's kind of sparse on the ground. You know, Final Fantasy 2 is even worse. Like, Final Fantasy 2 world's gigantic and it's empty. And so I kind of wish that rather than all these remakes and all this FF7 cinematic nonsense, like if they just went and just added more detail, you know, just added more towns and more quests and things like that to FF1. Because FF1 was a great game. It was honestly probably my favorite Final Fantasy. It's really well done. You could build your own party, whereas in later games, they would just say, you're fighting with Tifa and this is your party, you know, and you have to go with them. Whereas in FF1, you would construct your own party. And you'd have to think very carefully about how you did that, because it would greatly affect how the game played out over time. Anyway, so there is a turn order in all these turn-based games, and you're going to visualize it using a circular linked list. And the good news is, if you use the code that I give you, that's actually the bridges code. And so bullet point 5 is to visualize the turn order like this. Visualize it on bridges. So if you use the sample code, well, that's 2 letter grades. Okay, so that is building the circular linked list and having a turn order. This one is visualizing it on bridges, and I've put the documentation there. And you can see in the demo code here, it calls bridges visualize. And so you have to punch in your user ID and API key, pick a different project number. And so if you use the simple code I give you for the data structure, well, that's a letter grade called visualize. That's it. You look at it. Okay. Earthbound. Yeah, I've always wanted to play Earthbound. I've never had a chance. You guys understand? Make a turn order. And this could be somebody else's, you know, like if you have 3 people in your group, one person could be working on the world map, one person could be working on the class design, one person could be working on the circular linked list kind of stuff. I don't want to see this. I don't want to see this. It's visualizing right now students. If you hand me a Bridges web page that is just literally the demo code running, I am not going to count that. It has to be visualizing your heroes and monsters. Okay? You understand? You need to be visualizing your heroes and monsters. I don't want to see Gretel Shaney being visualized. Look, I ran the code. Here's a letter. No. You need to make it work in your RPG. Okay? You guys understand? So I had that last year. Like somebody's like, they just G++ this, punch in the bridges key, sent me a link, give me my 50%. They didn't even change anything. All they changed was the user ID and API key. There we go. Give me 5 points out of 10. Come on. Make it work with your RPG, right? So rather than a student info, right? Rather than a student info, have it be a actor. Okay. So, gonna name your monster Gretel. Yeah. Gladys. Starmagan. And this is the student info class, which you should probably just delete. Awesome. Okay. All right. Yeah, so extra credit. So I like giving extra credit on this homework assignment. If you do super cool, awesome stuff, and it's completely subjective, if I'm just like, wow, that's really cool, you get an extra letter grade. It just has to have some sort of wow factor where I'm like, wow, that's cool. One of my former students, actually 2 of my former students visited yesterday, Mason Twanta, founder of the ACM, and his sister Megan Twanta, who took 40 and 41 with me. And her 41 assignment, maybe it was a 40 assignment, was like a Fury Road based theme, and I thought that one was pretty cool. Maybe I can pull that up for you guys. And they had like timed events, so they use the chrono class or maybe timer and or clock, and they would give you a question and you had to answer it in a certain amount of time. It's added a little bit of pressure, to the game. So anything cool, I'll give you a letter grade. If I'm super impressed, might even be 2 letter grades. A lot of people do not have 100% on their partnered homework assignments right now, and that is currently dragging their grades way down. So I would go hard on this assignment, okay? I would go hard and impress me, okay? It's worth a lot of points. It's a 20-point assignment, all right? So go for the extra credit. It's worth it, all right? And yeah, cover art and music. This does not mean give me art and music. It means you make art and music. Do not just find some artist out there on the internet and be like, yeah, that's the music. No. I can find music. I had a student last 2 years ago submit, I composed this song, and they sent it to me on YouTube, and it's like, composed by so-and-so, and I clicked on it, and I'm like, oh yeah, you didn't compose that at all, did you? Just, come on. If you want to do cover art and music, you must compose it yourself. Okay, you must create the art yourself. And if you do like Photoshop things, like that's fine. You can copy and paste and things. Like, it's fine. But it's got to be an original work. Okay? So it's got to be, you can do samples and stuff like that, but it has to be an original work. Okay? The music has to go up on YouTube, in part so that it copyright checks it for me. So I know you're not just copying for someone else. And you're going to upload the art and the music as well onto Canvas so I can look at it. How'd you make it play? Open it up in a browser. It will not play in Vim. Vim does not have audio support. No, just put it up on YouTube, and then you can just play it when the game's running. Okay. And it has to be at least somewhat good. Like, I used to say it didn't have to be any good, and then students would just make these really low effort, like crayon images. Like, come on. It's like, come on, it needs to look at least somewhat reasonable, somewhat good. It's not super high standards, but at least somewhat good. Like, well, it's extra credit, so I'm, there you go. Just give me my letter grade. It's like a stick figure. Like, no. I am raising my standards this year. because I got a lot of crayon art last year. So, kazoo music, yeah. Actually, one of my former students actually got into the kazoo apparently, and was like at Santa Cruz, like he was known as like the kazoo guy of Santa Cruz, and he'd walk around playing the kazoo on campus or something. The vibrato flute, I don't know, MS Paint, yeah. No, I just, yeah, like just a certain quality standard. I can't specify it any better than that. I am looking for a certain minimum quality on your art and your music both to get the extra credit. Okay? You guys with me on that? Like, not high bar, it's not a high bar, but just I don't want to look at any more like kindergarten crayon drawings for extra credit. Give me my extra credit. You're gonna pass college because you did crayon. No. Come on. Or if you do crayon, if it looks good, more power to you. Okay? So that is the assignment. We got, 3 minutes left before the workshop. Please, on the chat channel right now, if you're looking for a group, post and go on to the Titanic flute fail sound effect. Or there's like the Jurassic Park. There's like the Jurassic Park with kazoos or something. So go ahead and on the chat channel, ask if you need a partner. Okay, I would really prefer it if you don't work solo on this, but if you can, if you want to, like, knock yourself out, I don't care. It's hard to do partnered assignments over remote class. I get that. I just think it's good for you to learn to work with other people, and it's also good for me because I don't have to grade as much. So the less grading I have to do, the better. So Groups of 3. Work in groups of 3. And then it takes the students, divides by 3, much less grading. Okay? So, I don't know. Figure it out. Figure it out on campus. I'm going to stop the streaming now, and I will play the Jurassic Park theme song where I won't get copyright struck. All right. So I'm going to hang out in case anybody has any questions, but basically we will pick this up on Monday. All right. See y'all then.